Hey guys, welcome to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2012, 10A, Problem 17, and it deals with number theory. I hope you all enjoyed this video and let's get started. The problem states, let a and b be relatively prime positive integers with a greater than b greater than 0, and a cubed minus b cubed over the quantity of a minus b cubed equals 73 over 3. What is a minus b? Okay, to start the problem off, we need to know the formula for the difference of perfect cubes as shown in the numerator of the fraction. And so the formula is a cubed minus b cubed. So this is the formula, and if we see here that in the numerator it actually itself is a cubed minus b cubed, and there are not any coefficients, so that means that we can straight up just use this as a result for simplifying the numerator of the fraction. And we see that we have an a minus b in the numerator, and we see that in the denominator we have the quantity of a minus b cubed, so that means that we have 3 a minus b's in the denominator. So we can just pull one out so that it can cancel out with the a minus b in the numerator. And we can simplify what's left in the denominator because it technically is the quantity of a minus b times the quantity of a minus b. So you can use the FOIL method or any method you want. At the end, you should get the result of a squared minus 2ab plus b squared. And so we can see that in both the numerator and in the denominator, we have a squared plus b squared. And then we also have ab. So we can set x to be a squared plus b squared and y to be ab. This will just make everything easier because now it's just one variable. And we can plug that in. So in the numerator, we would just simply have x plus y. And then in the denominator, we would have x minus 2y. And now we can just cross multiply. Okay, so here I have simplified everything, and now we get x over y equals 149 over 70. And because it says in the question that it's relatively prime positive integers, then that means that we can set x to be equal to 149 and then y would equal to 70. But now that we have x equals 149, we can just plug it in to this equation. So we would get a squared plus b squared is equal to 149, and then a times b equals 70. And so here is the kind of tricky part, because we now need to find out the factors and plug them in to see which set would satisfy these two equations. So we already know that 149, that is prime, but 70 has many set of factors, including 2 and 35, 5 and 14, and then 7 and 10. So 3 sets. And just right off the bat, you can eliminate 2 of them, so it would automatically kind of give you the answer, because if you plug 2 and 35 into the first equation, because we are plugging all of the sets into the first equation, then 35 squared is way more than 149. And so we can automatically eliminate 2 and 35. And the same goes for 14. 14 times 14 is definitely over 149 because if you don't remember all of those perfect squares, 12 times 12 is 144. And this is 149, so that means that 14 times 14 is definitely over 149. So we could eliminate this, and it would give us the answer of 7 and 10. And so that means that A could be 10 and B is 7. It's okay if A is 7, B is 10. It would just give you negative for 3, but in the end, A minus B is equal to 3, so the answer is C, 3.